In this video, I'm going to explain where the quotient rule comes from, so how we got it, and we're going to see it. We're going to discover the quotient rule for the first time, and then we'll do a separate video where we actually use the quotient rule to find the derivative. So the quotient comes from division. Quotient is the answer to a division problem. So say you have two functions that are being divided and you want to find the derivative of those. So what we're going to do is write j of x, which would be the derivative of, we're trying to find j of x, which is the function f of x divided by the function g of x. And our goal here is to figure out what does the derivative j prime x equal. Now, these steps here might not be exactly what you would have thought to do, but this will just show you how the quotient rule works, where it came from. So what I want to do is, I don't know how to work with a quotient, so I am going to multiply both sides by g of x so that I am now working with a product, because I do know how to work with a product. So now I have j of x equals g of x times, f of x equals j of x times g of x. So all I did was multiply both sides by g of x. Now I can use the product rule to find the derivative here. So that means the derivative of f of x, I'm going to run out of space if I write it right there. So the derivative of f of x comes from using the product rule for j of x times g of x. So I have the derivative of j of x times g of x plus the derivative of g of x times j of x. Now remember that our goal here is to find out what the derivative of j of x equals. So we want to get this derivative j prime x all by itself. So that's just going to require some algebra. If I subtract, so I have two terms here. If I subtract this term from both sides and then divide, I can get j of x all by itself. So I'll do f prime of x minus g prime x j of x equals j prime of x times g of x. I'm saying prime instead of derivative because it's just faster. Okay, and then finally, to get the derivative of j of x all by itself, I would have to divide both sides by g of x. I'll make a giant 1, and I'll be left with this right here. So I have the derivative of f of x minus the derivative of g of x times j of x over g of x. Now, when we were originally given a problem, though, we don't necessarily want to have the whole function, right, this whole thing in there. So you could stop here, but we're going to simplify it a little bit more because we know what j of x equals, and then we don't have to have 3 different things going on. So kind of moving over to this spot of my screen. So what I can do is I can take the j of x and substitute with what it equals, which is f of x over g of x. And then, of course, that whole thing was over g of x. So we can see that in the numerator, we have 2 terms. One term is a fraction. This is over 1, so really you could just make this one giant term. So this is a fraction with a denominator of g of x, and this fraction here has no denominator. So we have to make a common denominator so that we can subtract them. So the common denominator there would be g of x. So I'm going to multiply f of x by g of x over g of x so that the numerators have a common denominator. And then I'm going to subtract what was already the second term. Okay, and then instead of dividing that whole thing by another g of x, I can multiply by the reciprocal. So I'm kind of out of space here. But instead of multiplying or dividing by g of x, I can multiply this whole numerator by 1 over g of x. So now to simplify the numerator, I have f of x, or f prime x, g of x, minus g prime x, f of x. This should sort of remind you of the product rule, the derivative of one times the other, except that instead of multiplication, it's division. And then the denominator here was g of x, but I'm multiplying it by another g of x. So the denominator is the original g of x squared. So again, that's the final, that is equal to j prime of x. So that is the derivative of a quotient. That is the quotient rule.